Hello everyone, my name is Harold Campos and welcome to the channel. Today we will drill down on how to optimize Logic Apps integration with IBM MQ and Azure Service Bus. Let's start with what is IBM MQ. IBM MQ is a message-oriented middleware that was originally introduced in 1993 under the MQ series name. It runs on multiple platforms. According to IBM, it runs on 90% of the top 100 in the 2022 Forbes Global 2000. We have been providing MQ integration capabilities with Host Integration Server and BizTalk Server. Now, when we design workflows, we think of triggers and actions. Let's briefly discuss when to use which one. Triggers, a trigger fires when a condition is met. We have three triggers with the IBM MQ integration technologies. When a message is available in a queue, if a message is available in a queue, it returns a status only. When one or more messages are received from a queue autocomplete, the received messages are deleted from the queue. Or when one or more messages are received from a queue, browse log. The received messages are logged but not deleted from the queue. The second and the third are fairly similar. The main difference is that the third one will provide an option to abort or commit the operation. So it's safest. And this is what we recommend our mission critical customers to use. And the second one, it stores the data. It still persists the data because we always recommend using stateful workflows for this. But definitely the browse log is what we recommend for our customers who are interested in having this option to abort or commit, or like a transaction alike scenario. Actions, each subsequent step in a workflow that follows the trigger. The connector can browse, pick, receive, send, complete, and move messages. So then we have triggers and we have actions. Now, let's briefly talk about how to optimize the integration with IBM MQ servers. Let's start with the concept of handles. Handles, they represent object connections within the messaging system. They allow applications to interact with queues and other resources in a reliable and decoupled manner. Any successful MQ open call will result in an object handle, but in some scenarios we have found that some IBM MQ servers run out of resources, run out of handles. We get the MQRC handle not available error. To avoid that, we have suggested a formula. There is a great article prepared by Pedro Almeida that is available in our blog, in Azure Integration Services blog. I will paste the link in the description of the video that we recommend you to look into. So that way you will have enough resources available, and you will for processing on the MQ server side. Browse log. Using browse log allows customers to atomically retrieve and log messages from a queue in a non-destructive manner. I prepared a video called We Speak IBM MQ Part 1 last year, where I prepared a short demonstration of how this works. One of the prerequisites for this trigger it's that there is a state preservation feature to make sure that the messages are logged and available despite the instances where the workflow are being executed. To enable this, you have to follow the instructions in this link. I will paste it in the description, in the video description as well. So let me go real quick to the article. If you go to the article, then you will see that there's a section called Prevent Context Loss During Resource Scaling Events. There is something key here, right? Resource scaling events might cause the loss of context, right? So because of the dynamic nature of the elasticity of the cloud, for built-in connectors with a stateful mode enabled, this is the one that can be impacted. So that's why, to prevent this potential loss before such events can happen, then you have to fix the number of instances available for your Logic App resource. This way, no scaling events can happen to cause this potential context loss. So there are instructions on how to set it up in the article. I invite you to review it. Now, let's continue drilling down on the browse log. So there are a few properties that are key to optimize this trigger, right? And hence the whole integration. First of all, we have the max message count. We recommend this maximum to be 200. This is, of course, considering workflow overhead as well, time to execute versus number of workflow executions. There is always a degree of tuning that you need to conduct on testing. The next one is max batch size. The default is set to 100 megabytes. But this will depend on your network capabilities, right? So behind the scenes, these messages are added to a JSON collection, and this is a this is a resource-consuming activity. Wait interval, we recommend this to be lower than 30 seconds. The key here is to prevent HTTP disconnects. Let's remember that this whole infrastructure is based on HTTP. While behind the scenes there is TCP/IP integration, there are events that can affect the execution, like a scale in event or send a cancellation token. So then to avoid that, any value lower than 30 seconds will work best. The timeout interval is the time the browse log message will be held until we release it and put it back into the queue. Default to 30 minutes. And the polling interval that allows customers to post how often they want the batch to return. It's in a nutshell, is like throttling. Now there is a winning formula between the wait interval and the polling interval. The wait interval, if there are no messages in the queue, IBM MQ will wait until the interval expires. If there is a message in the queue, it will return the call to the connector. We recommend this in the scenarios where messages arrive trickling and not continuously for hours. It will return as soon as it hits the wait interval time, allowing reducing network chatting during low activity periods of time. Now, where the polling interval comes to play is that it will initiate when the trigger makes a call and returns a response. To optimize resources and response time, you have to set the wait interval to a value between 15-30 seconds and the polling interval to 1 second, for instance, right? So this will minimize network chattering during a slow period while allowing a quick response during a high load period. So the combination of both will, one, make sure that you are not incurring in additional costs, and two, will be optimized for your particular scenario. Now, let's briefly talk about parallelization. The following are recommendations to increase performance of workflows using the IBM MQ connector. What are the alternatives? One, use multiple logic apps. We don't typically recommend our customers to use multiple logic apps, just based on the level of integration, unless the service tiers in use do not meet the performance requirements. I understand that this is a general statement, but typically we've seen customers very well served with using just one logic app and multiple workflows. So let's drill down a bit into that. Use multiple workflows. While a workflow can access multiple queue managers, we recommend using one workflow per queue manager for high throughput scenarios. This is interesting, right? So a queue manager hosts a number of queues, and while there is nothing preventing you to read from to use different queue managers in a workflow, the triggers they tackle one queue manager now, right? So in that queue manager you can have multiple queues, or you can have multiple servers as well. So then we can reach out to queue managers and servers, but it's best if you are not doing context switching, but just kept in the context of one queue manager. But it's if you wanna do it, you can do it. Again, so these are general rules. You have to test your scenario, but we will advise you to use one workflow to have one queue manager. Inside a workflow, you have a couple of alternatives as well. You can create parallel branches with for each loop. We don't typically recommend this because the for each loops, they tend to be slower than split on, which is the next one, using a split on. We recommend split on because it will create an array of messages and workflows as much as it is allowed by the VM's scale out settings. Split on can run multiple threads in separate workflows and therefore could run in multiple VMs, allowing it to be more efficient, faster, and scalable. So in other words, but there is something that you need to consider when using a split on. The split on kicks off after the trigger has been executed. So if you have a trigger that operates, so then all of the new workflows that will be created in parallel when the split on is enabled will occur after the trigger execution. So in other words, all of the workflows that will be created just after the trigger. All of the actions that you have right after the trigger will be part of the new workflows that will be parallelized. Hope that was clear. Let me go to the demo to show how that works. One more thing about IBM MQ messages is the sizes, right? So IBM MQ supports messages up to 100 megabytes in size. ZOS or mainframes, they have this hard-coded, right? It's more dynamic in other environments, while the IBM MQ connector supports messages of 100 megabytes. We advise you to design your scenario in to achieve high throughput and performance. Consider different combinations of batch size instead of message size. For messages larger than 100 megabytes of size, you should consider using chunking. There is an article on how to do so. And as far as segmentation, the IBM MQ connector returns always all the segments. Now, what about multiple IBM MQ servers? The IBM MQ connector supports multiple IBM MQ servers. So when you, this is fairly similar to the MIQM feature. We can have a backup server name and port number, and then upon the unavailability of one of the MQ servers, so then we can reach out the next one. The standby server's name when using a multi-instance queue manager setup is entered in the connection properties, as it's shown in here. And finally, about security, the MQ connector supports one-way and two-way secure connections using SSL. One-way when the server sends a certificate for the client to verify, and two-way when the server sends a certificate for the client to validate. And then the client sends a client certificate, handshake. You have to remember that private certificates require an app service environment, which is a single tenant deployment of Azure App Service. Finally, you have to consider that the number of client certificates in the IBM MQ server can impact the performance of the SSL validation or the first handshake. Some consideration that for one-way TLS connections or server authentication only, for trusted CA certificate server certificates, all the trusted signing certificate public keys should already exist in the client's machine trusted root certificates store. No other logic app setting is required. And for the two-way TLS connection server client authentication, all the app service plans support adding a certificate to the local certificates store that can be used by Logic Apps applications running on the app server. For instance, Logic Apps sending a client certificate. Now, let's see if we can let's do this quick quiz about what we just discussed. Which one runs faster? You have a trigger that uses a browse log that sends messages to service bus, and you have it with a split on off and a split on, and also an array here, of course, right? So then you will see that this one is the one that will execute faster, because the one on the left will not enjoy the parallelization of workflows. You can add the parallelization in a for each for sure, right? But we just spoke about the for each and being split on and passing an array of messages much faster for high throughput scenarios. Now the next one is to have something like this, right? So you have a split on here enabled, and you have sorry, let me go to the next one. Okay, so then let's consider this scenario. You have trigger when a message is available in a queue, then you browse the messages and you have you loop through the for each, or you have a browse log with the trigger split on. Something that I wanted to mention is that this is a fairly typical scenario that we have with our that we've seen in many customers, and we still don't understand why. So some of them they are using this trigger and action as opposed to have just the browse log trigger, right? So the browse log trigger is available for you to use, right? And it not only sees if there are messages available, but it brings them up, right? In this case, you query to see if there is a message, and then you browse. So this is not as efficient as this one. I think this, when message is available in a queue, just the one that sends a yes, no, right? I mean, it can be used if you have a very specific business scenario, but if you are interested in bringing the messages, so then we'll advise you to go to the second one, the browse log with the split on. One more scenario, which one runs faster? To have one large batch workflow or multiple duplicated workflows with smaller batches. We've run multiple tests, and we have arrived to the conclusion that this configuration is much faster. It enjoys the parallelization of the Logic app, right? And it operates much better. Of course, if you are split on, right, which is the case because you see that we have the complete messages here. If you are the split on, it's even much faster. So we invite you to test this configuration. Now, let's talk a little bit about the integration with Azure Service Bus. So we have our own. We discussed Service Bus. Well, we have discussed about IBM MQ, right? So now let's talk about our messaging platform, the Azure messaging platform. We have a message queue broker, Azure Service Bus, that connect apps on an enterprise message queue in a PubSub platform using open protocols, including JMS 2.0. We have Elastic PubSub broker, Azure Event Grid, publish and subscribe, MQTT messages and HTTP push and pull for delivery of discrete events. And we have Stream Engine, Event Hubs, Cloud Scale, low latency, streaming platform supporting Apache Kafka, and MQP clients and services. And finally, we have our event stream processor, Azure Stream Analytics, real-time stream processing and analytics engine with rich development tools and low no-code editor experiences. And all of these, more than 75% of our largest customers, they use 2 or more of our messaging services. They are reliable, they are modern, they grow, and they are available in the cloud, right? Let's add to that the fact of the support of AMQP, MQTT, Kafka, and JMS. Now, if we drill down into Service Bus, what Service Bus provides, we have 2 tiers. The standard. Well, there are 3, but the ones that you will likely use are the standard and the premium. In the standard, you have availability of AMQP and HTTP REST, polyglot SDKs, filters, actions, sessions, duplicate detection, role-based access control, a number of goodies available with the standard. Now, if you were to decide to go to premium, so that you have dedicated resources, GODR, large message support, JMS 2.0 compatibility, availability zones, virtual network service endpoints for VNet integration, partitioning, and also you have all of the cloud native patterns available for you to use, right? So we talk a lot about microservices, domain-driven design, how is it that we can preserve bounded context and all of those things, right? So they are a reality, right? They are a reality, and we have the technology that enables them and that customers use for their mission-critical environments. So then all of these patterns are available for you to use with Service Bus. Now, all of these patterns, I mean, you might be familiar with most of them, right? But something that you have to consider is that um, you have to use the right tools for the right job. So then we have to make sure that you leverage the capabilities of the product at its maximum. We have provided guidance recently for Logic Apps and Service Bus. There is a great video by Kent, where in order delivery using Azure Service Bus Session and Logic Apps for standard. And there's been a couple of great blog articles by Divya Sarnkar about concurrency and session support for the Service Bus built-in connectors. We'll paste. I'll add the links in the description. Now, why IBM MQ to Service Bus? Right, so we've just seen that IBM MQ runs virtually everywhere. It also provides multiple bridges for legacy systems such as CICS, IMS, etc. Right, so MQ has been around for many years, and it has created a large customer base, and it's a very rich messaging system. Right, for legacy systems, it's pervasive. Customers who are extending their workloads to Azure require a reliable and performant bridge to share messages with Azure Service Bus. This is part of what we call modernization, right? Application modernization. I work a lot on the mainframe and mid-range modernization space, so I can tell you that MQ is everywhere. We see it in IBM Z systems, ZOS, ZTPF, CVM, Z Linux. We see it in Unicy systems, IBM Power Systems, Fujitsu Spark, Sun Spark, SuperDOM, the IBM Cloud, the Amazon MQ. So it runs in our cloud in virtual machines as well, right? So then, if you are pursuing if you need a bridge for Service Bus, Logic Apps becomes the bridge. So that's why we keep adding capabilities to our connectors, so then our connectors can seamlessly integrate with MQ and then act as a bridge to interact with Service Bus in an enterprise manner. So now let's quickly jump into a short demonstration. Let's see if I still have a session here. All right, so this is my IBM MQ system. I have a little tool that allows me to send messages to it. I will show it to you in a second. Let me go to the and I have a Service Bus namespace here. It's called host integration that has 3 queues: MQ1, MQ2, MQ3. This is Service Bus, by the way. Okay, this is not MQ. This is Service Bus, and I have created three queues. And these 3 queues, they already have some messages because I was running some tests. And I have here 3 Logic Apps. Sorry, 3 workflows in this Logic App HIS Dev Logic App. Let me show you each one of them. So I'll show you the MQ1. This is one that has the trigger, the browse log trigger with split unenabled, and send messages to Service Bus, and it completes the messages with a commit. Then there is let me show you the next one. Second one, it's another workflow. This one has a split on, has it in off, and then you have the browse log trigger, and then it does a for each, and then send messages to another queue. It has a commit and an abort, completing the messages and a for each. Right. Something important to consider is that if you enable the split on, you don't really need to have a for each, right? So you can just leverage the you can just send messages, group of messages, because you will be sending an array of messages, right? So let me go then to the next one, MQ3, and then you will see this is similar to what we've seen in some customers. The trigger that returns a status, it does have a wait interval, and then it browses messages and then sends multiple messages as well in an array, and it completes them. Something that you have to be very mindful of is that when you're running service bus, you have to know exactly which tier you are running up to, right? So remember that you have a max message size of 256 kilobytes for basic and standard. So that means that if you have larger than 256 kilobyte messages, then you will get exceptions. And it's very easy to reach out this limit when you have batches. So if you are thinking of batching, you got to think carefully about the number of messages that you are sending to service bus, right? Unless you have support for max message size, which is available in premium. I don't have it available right now, right? So let me go to MQ1. Let me run some tests here. So I'm going to send 100 messages, right? You're still seeing here, right? The 100 messages here, 10, 20, right? So let me just go now to the MQ1. And see they are running. Let's go to see if this is growing. Yep, it is. Now let's go back to see how many messages are being processed. Let's see, where is it taking too long? Okay, so it was done. It's just it was done in the complete took some time. Right, let's see, in Q1 it was a success. Right, now let's see what we have here. Yeah, it took a while, so let's go to the next one. Let's refresh. Okay, so finish it. Let's send 10. You see here, so now you have them available here. It was real fast. Yeah, it took 335 milliseconds to send them. Right now, let's go to the next one, the MQ2. Let's send them to MQ2. Yeah, I did it already. Let's go here, fresh. Q2, A41, A51. Yeah, that's done real quick. So yeah, they were all instances. See, 332 milliseconds. And now let's do the next one. And the reason why I had so many failures is because I was exactly hitting that limit that I mentioned of the batch of the 256. So I had to continue playing with the sizes, reducing it to a point where it made sense for my configuration. But I'm sure that if you're running with large messages in Service Bus, then you will require a premium tier for VNet integration as well. So let's take a look, right? So this one just ran. Let's go here. Let's see if updated. Yeah, so it's 70, right? So what we are seeing here is that the larger the batches, it takes more time. So let's increase the number now again to see how is it that it grows. Let's do 1,000. So let's do 1,000 messages, right? And now let's take a look. Yeah, so it's doing it real fast, right? So some of them will take a bit longer, right? But it starts getting stable with the runs, right? So that's the reason why you have to keep looking for the optimum scenario, which is going to be a combination of these parameters, right? There is not a lot of time for me to do this demonstration larger, right? But I advise you to test all of these different variations of yeah, you see, so you process the messages already. They are in Service Bus already, right? So one of the recommendations that I have is play with all of the different combinations that you have. This is using browse log, and this is using split on. So you see how fast operated these 1,000 messages, right? And the same is going to happen with the next ones as well, right? So let me go to the next one. Real quick. See, 1,000 messages. Yep, it's growing, still processing. But the previous one was definitely faster, right? Because it had the split on enabled, right? So this one is using the MQ2 is operating using the for each, right? So we will have to, if we were to use the split on, we don't really need the for each. It will just work as it is. So if we go to overview, right, this should be reflected. You see smaller times because this is doing it individually, right? So that's the reason why you have to make this adjustment. So now let's go to the next one, MQ3, the last test, final one. Q3. So you see here, right? Let's go back to MQ3, right? Designer. MQ3 70 has to grow to in 1,000 by 1,000. Refresh. Yeah, there you go. So it did it. So again, so it depends a lot on what you are pursuing, right? So all of these options, they are available for you to test all of these different patterns, right? But take into account that some of the patterns, they like in this case, we are not running parallelization. This is just one workflow that is doing the work, right? It took 640 milliseconds, 159 milliseconds, right? In these runs. So if you are trying to reduce this time, focus on running tests that will likely include a split on, getting an array, and do parallelization, and create more workflows. So I think that is the message that I want to leave you with. Finally, thank you for your time. Thank you for listening. You can follow me on X at hcampusu, or you can email me, or you can add me to LinkedIn, or follow me on YouTube as well. Okay, thank you, and have a great day.